Hi there, welcome to another episode of Harrison Hobbies. Today we are going to continue our build of the 2X 18 volt power supply adapter to M18 battery project. So a couple of weeks ago I released a video where we built the second adapter here. We were using XT90 connectors on it instead of XT60. We validated that it had the ability to produce power, so theoretically it's ready to go. Today's video is going to be a little bit more tactical than the last video in that we're definitely going to try the table saw with this adapter here. I felt a little bit bad. The last video was maybe a little bit clickbaity since we didn't technically test, but there was a lot of infrastructure to start developing there. And in order to build the infrastructure that was used in that video, it took a little while, and I certainly didn't want to omit anything in case you were following along and also doing a project similar. So the game plan for today is going to be testing out the inverters here. We have our oscilloscope right here, so we're going to be able to test out the waveform and figure out exactly what these are producing. Again, in previous videos, there are some comments saying that these are going to be a square wave where it charges up a capacitor and then dumps it just a whole bunch of times to kind of simulate that, that continuous DC power. I assume that they're not like that, but we need to know. And so based on that, we will be able to hook up just one, see what the waveform is, then we'll be able to hook up the second and see what the resultant waveform is. We may need to end up using capacitors here to help smooth that current out and provide a little bit of buffering. And then the final piece is going to be, once we have all this, we're going to build ourselves a 4-to-1 adapter. So what that 4-to-1 adapter is going to do is going to allow us to attach instrumentation. It's going to allow us to attach both of these power supplies here. And should we choose to create an auxiliary power supply, such as a bunch of capacitors all wired up in parallel to be able to absorb some of that current whenever it's off and then dump it to assist with startup, we have that ability to funnel that in. But if we were to use a regular battery in line as an additional startup circuit. So the end result of this video hopes to be that we can get the table saw onto the bench here, we can hook it up to some power supplies, and we can actually get it cutting wood without the need of a battery. So if we can get all that done today, then we're going to claim success. As a follow-on to this video, I'm planning on a third, potentially even a fourth video where we start to employ the boost converters that we talked about previously, also hooking up our thermal camera and looking at the heat output of these, also using our big load tester there, the carbon pile tester, to figure out what kind of output these can actually have in both, a sudden load as well as a gradual increase, and then comparing that against something like the 12 amp hour 18 volt battery. So I think we've got a lot of work to do. The theme of this video is probably going to be Sam sits and solders for a few hours, and then we use some editing magic there to make that a minute or two, so you can see the details there. But I think we're going to have a lot here. I am hopeful that this system will work, so let's dive in. So we're about to test the waveform of one power supply. We'll get one going, and then we will hook up both of them in parallel, and we're going to look at it all on the oscilloscope. As you can see here, I've got my oscilloscope probe. I have it hooked into the negative and the positive. So I'll plug it in, and we'll check the waveform, and we'll kind of discuss that. Okay, so now we can see in the waveform here that things are going up and down pretty quickly. So the power coming out of this isn't exactly clean, but it's certainly not the square waves that everybody was anticipating, or I say everybody, but some people were anticipating. But we'll get both of these going now. Okay, so now they both have a load. We're seeing 20-ish volts on both. They appear to both be putting out plenty of power. I don't really see anything awry here that would lead me to believe that, that this was going to be an issue. So I can say, I guess quantitatively here, based on what we're seeing on the screen, that we are good from being able to sync these two together, and we have a nice clean waveform. Certainly clean enough that I don't expect a lot of crosstalk between them. So I guess the next step is let's solder up some adapters so we can get both of these to go into our larger battery here. And we will we'll drill a hole real quick on here and we'll solder in some tabs so this becomes a battery that looks just like this, but instead of having the XT60 connector, we will have the XT90. So let's dive in. Quick update here, things as always not going to plan. This is going to be this is an OEM 9 amp hour battery from Milwaukee. And you can see it's very heavy here with MOSFETs. It's got a lot of charge circuit on here. And so this is what a proper Milwaukee battery looks like. If you look at our planned 5 amp hour here, it has, and actually let's compare that. This is the original, the 2 amp hour that we have, that we've been using in all of our testing, right? So this is quite a bit different design, right? We have like all of these terminals here are just plugs that are held in, and then we have wires that are soldered to the board here, versus this is an actual assembly, much like the OEM battery. This one here I've been hooking up, and it's looking for a nominal voltage through these in order to detect health, right? If we were to hook up electronics to the channels here so we could monitor, the system could monitor the voltage, this would in theory work fine. However, I just went on to Amazon and ordered another. This is the EPOWON, the EPOWON 5 amp hour, in hopes that it will have the same format here, right? Like the non, I guess we could call it the less safe version here. And for those that were interested, I did this a long time ago, but this was the bank of capacitors that I included in this battery. So these are the capacitors here. They're lined in series with this, in parallel with this. So whenever you hook up the power supply to it, it charges all of these. And then once you apply a circuit, this and the power supply would run in parallel. So in theory, you'd have the current from these and from the power supply to help with starting. Never did a lot more testing on these to see whether it actually works or not, but I thought it was, it was kind of a neat little setup how well it fit into there, and you'd never even know that it had capacitors in it. Just wanted to provide a quick update here. I guess I've used this a little bit, but I did have a spare EPON battery here that I've probably had for a little while. It looks like I've probably done some sanding with it, but this is functional. It's a regular battery, still has the 18650s on it, and I believe that this is going to work. So I did order a brand new one of these off Amazon. I also ordered, like I said, it was a 5 or 6 amp hour, so we'll be able to do a teardown of those, and I can provide better information on the channel on models to get that will actually work. But this does have the right, it's got the contacts here that are soldered, and it doesn't have any battery voltage monitoring on here. So theoretically this is going to work. We're going to get this soldered up. As we saw even on the, the Milwaukee, the 9 amp hour battery here, right? These terminal traces really aren't much difference in size, right? I mean, okay, so I guess the 9 amp hour is about twice the width of the smaller 2 amp hour third-party Super China here. So yeah, that will handle a little bit more load carrying capability. But even on this 9 amp hour here from Milwaukee, it's an OEM battery, you're not talking about oodles and oodles of, just like super thick wire here connecting everything. This is still relatively thin, relatively small. So we'll get this battery here, we'll pull the cells out, stick them onto a charger, get them into a safe voltage for storage, and then we will solder in our larger XT90 plug onto this. And just for fun, we'll probably tear this apart and pull the cells out also. This thing is no good. It shows full voltage on here, and once you apply a load, it'll last for about 15 seconds and drop off. So once we tear these apart, we'll get a little bit more data on that potentially we can share here. So the game plan here is just going to be to go in and cut all of these tabs. We can trim back the metal on everything but the positive, which is going to be up here, and then the negative, which is over here. And so we'll, I guess we'll just do a quick fast forward on that. From forever ago, we should remember that the very top corner here and the very bottom corner here are going to be our 2 contact points that actually have power. So these 2 will bypass everything else here. We'll hook up our power supply here just to verify this, and we'll be able to pump 18 volts in, or 20, or whatever it is. And we should see that the entire system is going to energize based on these 2 contact points. So we've got our tester here. We're going to set this at 20 volt. Up at the head here is going to be our positive, here. So if we look here where all of the contacts are that make contact with your tool, this tab here sticking out is going to be your positive, and at the bottom here near your switch, this contact is going to be your negative. Positive at contacts, negative at switch. We have that hooked up now. We will set an output here. We see the 4 lights indicating that the battery works. We can press this again. It works still. If we take our drill and hook it in, okay, power supply doesn't have enough current to start, but it worked fine. So I have no doubt that that we've done right here. So we can go in and clean up these tabs. Ooh, these go flying. Make sure you're wearing safety glasses. Buy yourself a decent pair of flush cutters. Okay, so now we are left with positive and negative. Okay, so we've been trying to get the thicker wire to solder on, and there's just not enough mass. So for this one, we're going to go back to the smaller, what is this, 14 gauge instead of trying to use the 10 gauge. So hopefully this will work a little bit better. So here is our battery. So we have positive going to positive and negative going to negative. Oh, there we go. Hey, we got it. This version's already better than the last. Big old empty shell of a battery. Functioning clicky tabs. Now we will use our XT90 connector on here. We're going to take the flat side of the XT60 connector here, and that's going to become positive. Now we have our newest battery. So let's hook up our power supply real quick and just give ourselves a sanity check that it's going to work. We got 3 bars, so let's double check. So far, looks like it's doing great. So let's clean up here a little bit and we'll get ready to make our 1 to 4 squid. So to make all this happen here, building the squid, we are going to be taking 4 adapters, right? So we're going to, just for fun, we'll probably, let's say we're going to make this 5 instead. So what we're going to have is, we are going to have, we'll say 2 male XT90 connectors, and we will have 3 male XT60 connectors. And so what we're going to end up with is we're going to have 5. So we're going to have the 5 here, you know, 2 XT90 and then 3 XT60s. And then that's all going to combine. Positives on all of those are going to be joined together. Negatives on all those are going to be joined together. And it's going to come out to 1 XT90 connector. So this is going to be a female. And so what's going to happen is we'll be able to take, you know, for example, this male, we're going to be able to plug the power supply into it, XT90. We're going to take this male, XT60, plug the other power supply into it, and then both of those will come out in this XT90 here, female, and then we'll have the other XT90 male and the 2 XT60 males kind of along for the ride there. And so with these plugs, we'll be able to hook up an oscilloscope without actually having to penetrate wires or find, you know, a way to kind of jam that into a battery or a terminal to see what our voltage is. We also have the ability to hook up, you know, in our earlier testing, we had this battery, right? And so we have these leads on here, and it comes out as an XT60 female. And so we'll be able to take this battery and we'll be able to plug that into another one. And so in theory there, like if we really just can't overcome the inrush current to use the table saw or any of the other larger tools, maybe we supplement with probably not a 2 amp hour battery, but maybe a 4 or a 6 or a 9 or a 12 amp hour battery, just so we can get everything going. And if we really want to talk about, you know, a lot of potential power, you know, we could build a bank of those. And so, you know, if we think of the torque test channels use case here, you know, being able to take this and then boost all these in the future to get, you know, a sustained 20 volts or even maybe a little bit more, 21, 22 volts, and be able to hold that with all of these power sources all contributing concurrently to that one end source, we may have, you know, completely consistent power at pretty much any voltage we choose through, you know, all these certain means. You know, the thing that we didn't talk about there, I think that we did talk about briefly, was, you know, we also have these larger 1,000 microfarad capacitors. So potentially, you know, we can look at inrush current and using these as a power buffer. We've got all kinds of tools at our disposal here. So again, we'll just kind of treat this as a quick little time-lapse opportunity and hook all this stuff up together and see what comes out of it. What we want to show now, so we have the negative going to the flat side, positive going to the flat side, negative going to the curved, positive flat, it's been a long day now, positive flat, positive flat, positive flat, and positive flat. So all of these heads here now are linked in parallel to this. So after a brief break, we have got the system ready here. We're going to do more or less a moment of truth. We've got our power supplies here, we've got our extension cable here, and we've got our 4-to-1 squid, I guess a 5-to-1 squid here. So configuration is going to be both power supplies here, both are going to feed this. We're going to use our extension cord here to get this to where we want it to be. So if we recall from last time we'd learned early on that it's best if you plug that in. I guess that was the other one. So the batteries don't light up anymore. I don't remember if that was an issue on the other battery. And I say anymore. It's a brand new tool. But it seems like we're totally fine here. And now, I guess, we're hooked up to the new power supply. Let's just put it in to the table saw for the sake of completeness here and see if maybe this one's a little stronger. Okay, so now it's in the table saw, and we'll turn it on. Let's remove this and see if we can get that to go one more time. So it certainly seems like it's got a little bit more power, but now let's plug in our 4-to-1 squid. 5-to-1, I keep saying 4-to-1. So we're going to put in the output of the squid into here, and then we're going to take our current one, and we're going to test to make sure that there isn't some kind of crazy amount of resistance built into the squid. So we're going to do the exact same test. Audibly, sounded the exact same, so we can assume that there is no major resistance in there, which would reduce our overall current capability here, resulting in this not working. So now we're going to plug in the loud power supply. Okay, now we have both power supplies going. We're going to put the battery in. The one key light that this comes with is on. Now let's test it. Moment of truth. Interesting. So let's plug this back into our battery here. So I plug our battery into our drill. So the reason we're not making contact is because I'd pulled out all the 18650s, there's a void space, and the circuit board has actually just dropped down. So right now you can fit your finger in there. So didn't think about that. We'll need to pull that up and try again. So let's cut for a second, fix the battery, figure out a way to ballast it up a little bit, and then we'll start recording again. We've got some wood blocks that were about 3/4 by 3/4. They're roughly the same size as an 18650. We're just going to glue them into the shell here. And I believe I just took the battery up into one of these to verify that nothing, I say battery, the shell, the electronics here, to make sure that we didn't burn anything out. And I had the realization that we didn't see the LEDs whenever I pressed the button and made that comment a little bit earlier, because that board was already sinking and those LEDs were no longer making contact with light pipes. So they were just kind of shining off into the darkness. So I'm going to get this glued up, put back together into the machine, and then we'll start recording again once we're ready. Okay, through a brief bit of movie magic later here, we have our stringy battery. Now everything seems a little bit tighter with that wood. It fit in there perfectly. Again, didn't make a single cut to any of those or sand, so I got lucky. Everything in here seems a little bit more fixtured. I guess in hindsight, the signs were all there for me. These little, I guess these little clip buttons, these things were starting to, they were binding. I guess they kind of still do a little bit, but they're a lot better than they were. So that was probably indicative of the board was already falling whenever I was screwing with it a little earlier. But so we got this now. So let's get we'll get the big power supply plugged back in. Just because that one doesn't have any fans that run, evidently. I'm not sure if maybe they would, but we got our LEDs now, the 3 LEDs, and when we press the button, they turn back on. So that's what I would have expected here. And yeah, everything seems to be working a lot better now. We'll assume that the reason that the table saw didn't work before. Maybe it wasn't making good enough contact, and the reason that it just instantly stopped, potentially all of the vibration of the starting may have dropped that, that circuit board down, and so it never even had a chance to contact. So we'll get all of our power supplies hooked up here, and we'll check and see again. Fingers crossed. Okay, so I guess now the next step here is going to be to set up the GoPro, and we'll use an inline current meter to figure out what kind of amperage we're actually pulling here, because, I mean, 2 power supplies here, each with 66, 100, and so we've got 120 amps, and so the question would be, does this actually take more than 120 amps? So let's hook up the current meter and figure out what we're actually seeing here. Okay, so we're seeing just kind of a parasitic leech of it running the 1-key circuit and all of the Milwaukee electronics on here as 0.67 amp, and I guess let's just start it up and see what happens. Try that again. We'll do a couple of tests here. So let's unhook the small one here, and we'll see with just the big one. Try that again. It really wants to try. Okay, we'll stop screwing around here. We're going to hook up this little battery, right? Totally sacrificial, a little, what, 1.5 amp hour battery. We're going to put this in line and see what happens. And hopefully we don't short it out. And let's turn it on and see. Well, we've had it one time. Let's hook up, I guess let's go with all 3 and see what happens. If we're going to burn the place down, we might as well do it right. Oh. Interesting. Well, I was worried that one was backfeeding the other. I guess on their own, they just don't have enough power. But you stick in an extra battery here like this with just the pigtail, and you backfeed it, things change. Now let's see if maybe we can do it with just the 2. Interesting. So now it is not cutting out. So there's potential that the saw is the thing that's actually failing on this, right? Because I don't hear these cut out anymore, and I'm able to just flip the switch and keep going. So that may actually be the saw itself cutting out and protecting the batteries in this more generous configuration, right? It detects too low of a voltage. Back to it here, we've now got our multimeters hooked up with voltage and current. We'll try to keep this one here lit up. We're seeing around a generic draw of around 6.7 amps, which is, sorry, 0.67 amps, which is running the machine. And then we're seeing around 19.6 out of the power supplies. If hypothetically, let's just for curiosity's sake, say that we want to add in this load battery, 19.6, 19.7. So we can see that that battery, fortunately, it isn't fully charged up, is it? It looks like it's missing a bar, but it is completely in parity with the other two power supplies. Basically, it's, what, a fraction of a volt. So if we were to, I guess we'll start this thing up and we will get more figures here. Okay, now if we remove this from the circuit, let's see if anything else changes. Give it a second here. We know that we've been able to do this once, so I'm sure it's just a matter of luck. Okay, I think that the next step now is going to be to cut a piece of wood. So let's start it one more time and we'll do the exact same test. This time we'll disconnect the battery and try. No battery. Okay. One more. So I was pushing my darndest there, and seems like it was starting to bind up. It has nothing to do with the battery system, but you know, for the first chunk of it, I was able to go in really, really well. And then it looks like maybe I don't have the blade guard here seated correctly, because it was starting to bind up once I got over here to the aligner. So I guess we can say quantitatively that we have now powered the Milwaukee table saw on plug-in adapter. We're having to cheat a little bit to make it work, and so I think tonight we can fiddle with these and see if we can make that improvement. I want to see if we can make this a self-contained apparatus that doesn't require plugging and unplugging a battery. So since we already have these 4 capacitors here, I figure it may just behoove us to go straight to getting these soldered up all in parallel with each other so that we can also use these to help with the starter circuit. I don't know for sure, but these may be just enough to give us that extra little bit of kick of power on demand to get the system going. They may also not be. Let me get these soldered up. We'll do another quick little time lapse of getting this done just so you can kind of follow along and see the high level steps over the course of, 30 seconds or a minute or so. And then once this is done, we will stick it back onto the table saw and see if there's any difference there, and I guess see how that works. Okay, so the first thing we're going to do is glue all of these capacitors together. We're going to make it so, as from this perspective right here, our negatives are all on the left and the positives are all on the right. we, in theory, have a fully operational capacitor bank. All of these, in theory, are all on the same channel. And so now, if we were to put this on, we would see 0 volts. That one has a little bit. 0 volts, basically. So now if we were to take this and load, so if we grab our positive and negative, here we'll do white is black, yellow is white, yellow is red, and we were to quickly jump these with black being white. Okay, now there's a little pop right there, probably saw that, and now if we test this, this should be full. In fact, these actually had enough to eke out 19 volts. So now, if we're fully charged here, which if we're at 19 volts, we likely are, and we were to plug this into our, probably gonna have to use our old battery since that's got the old style of connector on it, right here. We should be getting enough to actually see the lights turn on. Oh, we get a flashing red, but if we, alternatively, we're just going to keep this on constantly here. And now we have 3 lights. So now we have capacitors here and we have capacitors in here from a previous build, but we have power. So now there is no connection. And if we were to grab something like, let's say, the rover light, which I think is probably, I don't have anything lower power in here that I can think of. So we're going to take our battery, plug it in, and see if we can keep this light powered briefly. Now that was all 100% off capacitors. So that was a fraction of a second, but the fact of the matter is it has enough that it can actually run a piece of equipment. So if we were to do that one more time to prove that that wasn't some kind of fluke or something weird. 1, 2, 3, 4, 5. Now, if we plug back into our light again, and we turn it on, we get half a second of light, maybe a full second if you're generous. So I'm not saying that this is going to save the day here on our table saw, but I think if anything, if we were really trying to find a never have to use a battery solution, this is going to be the closest thing that we've got. I mean, what would behoove us here is to probably have a bank of like 8 or 10 more instances of these. And then we're talking about some perceivable actual runtime. But again, these things aren't necessarily, I mean, they're not expensive, but to do an array of, 40 or 50 of these, first off, that's a lot of space, right? That's like an entire smaller pack out case of nothing but these for a starter circuit, which may be what we end up having to do if we say, hey, the battery used as an auxiliary starter is a bit of a cheat here. Then this is here, right? And with these, the way that that's working is we plug it into the circuit, it dumps a whole bunch of power into them, and then we wait a couple of seconds, and then we're ready. And then the second that that piece of equipment comes up to speed and the voltage gets up again, all that current flows back in. So these just sit there fully charged as kind of, I mean, they're basically treated as a wire in the system once they're fully charged. So, sorry, I'm explaining a capacitor. That's totally out of field. So let's, we'll get cleaned up here. We will put the table saw back up here and we will try, instead of using that battery, we will use our capacitor bank. The reason that our old battery pack would always spark whenever we were plugging it in was likely because it was charging the capacitors there, because I haven't noticed that with this, that's just the brain box. So, anyhow, we have the setup here again, right? We have our bank of capacitors here. It is plugged in just like the battery was into our 5-way adapter. We have our 2 multimeters here. We've got the long extension cord going to this, and we have our 2 power supplies. We're going to get those plugged in right now. Okay, so moment of truth, okay? The capacitors, in theory, are fully charged because the entire system is now being held at 18.9-ish volts. 18.9. We really need to get a boost converter here, but let's give it a shot. Okay, could it be that the table saw was actually getting enough power? Let me rephrase. Could it have been that the power supplies were in fact continuously delivering power, but the table saw that drop in voltage and said, whoa, something's wrong with the battery, let's stop. Because whenever it would start, it would go chook, 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 and then the blade never freewheeled, which leads me to believe, since it has positive control of the core there, the stator, that it may have been the saw actually tripping itself out. Now that we have those capacitors, and we saw, you know, whenever we were using that light, half a second-ish of power, that may have been just enough to keep the system from ever dropping in voltage until this thing got all the current it needed to get up to speed, and these things were able to kind of level out what they have. Let's do a couple more draws real quick here and confirm. No issue. No issue. No issue. Yeah. Okay. So there we have it. We don't need a battery as a starter circuit. That is there. We have now proven that we can run a table saw. We had to finagle. This is, again, this is nowhere near as elegant of a solution as I wish the system could have been, right? Just one single inverter box to a battery, into the saw, call it good. But in the end, we have built a system that is fully capable of getting our saw to do what it does. In the end, this is the scientific method at play, right? I mean, we've failed a lot tonight. We failed a lot over the course of the past couple of years trying to get this going. So, as with all of these videos, this is a series. It's designed to help everybody learn. The more comments we have, the more likes, the higher up this is going to go in the algorithm. So if you believe that what I am providing here is valuable to the Milwaukee community, and hopefully enough that we can prove to Milwaukee that they should build one of these so I can stop making these videos, you know, likes and comments here are going to help this video rise a little bit so it gets to more eyeballs. And as always, reach out with any questions. Make sure you stay subscribed, because again, there will be more of these videos here, and we'll start doing collaborations, hopefully with additional channels on other stuff too. Again, this is not my job. This is just kind of a fun little hobby I have here. But it's been a great journey so far, and I hope that we can continue. So thanks for watching. Check back soon for more videos.